Okay, students, so we're back here with trigonometry, part 2, and we're just going to do a quick review, all right? As we build our skills, do it over and over, we're going to get quite good at this, all right? So we're going to find the sine, cosine, and tangent for both angles A and angle B, and I'm going to write each as a fraction. So before we even start this, remember, so, ka, toa, all right? And what this means is sine is going to be opposite over adjacent, or hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. These are ratios of side lengths that determine angle measures in a right triangle. That's why they're so popular, so famous, so important to life as we know it. So using SOHCAHTOA, first let's focus on angle A. All right, with respects to angle A, well, the hypotenuse is always the hypotenuse. That never changes. It's always the longest side opposite the right angle. 15 is the adjacent side. It's the adjacent leg. It's the leg that touches angle A, and then we have the opposite over here. So remember, using SOHCAHTOA, we have sine of angle A equals the opposite side over the hypotenuse, which is 20 over 25. Which reduces to 4/5. The cosine of angle A is the adjacent over hypotenuse, which the adjacent in this side is 15, hypotenuse is 25, it's 3/5. And then the tangent of angle A is the opposite side over adjacent, toa, so 20 over 15. All right, and then reduce that to 4/3. All right, those are the fundamental trig ratios. All right, we're going to do the same thing, but for angle B. Now remember, it's all about referencing the given angle. The hypotenuse never changes, but now the opposite leg, the angle B, is 15. Notice how the opposite and adjacent sides switch depending on which angle we're talking about. And remember, we only do trig for the acute angles. We never do it for the right angle. All right, so then we have, and again, you might want to just try to do this on your own. Don't listen to the video, don't watch the video, and then you can check your work and see how you did. But this time sine B is going to be 15 over 25, which is 3/5. We always like to reduce. Cosine of angle B is adjacent to 20 over hypotenuse 25, so 4/5. And then tangent of angle B is opposite, so 15 over adjacent 20, which reduces to 3/4. All right, so these are just writing the trig ratios. We're not solving for anything. This is the most fundamental stuff we can do. But again, you have to have the fundamentals down, the basics down to be able to do the complicated, fun problems. All right, so moving right along, we have this right triangle ABC is pictured below. Which equation gives us the correct value for BC? Then solve for BC. All right, so we need to solve for BC. It's this side right here. This is our reference angle. So notice that this is the opposite side. So since we have opposite side, using SOHCAHTOA, I can automatically knock out cosine. Because in SOHCAHTOA, cosine is the only one that does not use opposite. So cosine's eliminated. So I'm going to knock out answer B. All right. Now let's just look at actually, we'll keep that there. Let's look at this. Well, sine 32 is opposite, and we need the hypotenuse. Well, that doesn't make sense, because then what we would have needed to have is sine 32 equals opposite, we'll call BC, over hypotenuse 10.6. So that doesn't make sense. That doesn't work. All right. Cosine, we said that's the only one that doesn't use it. Well, then tan 58. So hold on a second, people. Now it's saying, what's tan 58? Well, where's it getting 58 from? This angle has to be 58 degrees if the other one's 32, triangle sum theorem. So now we're investigating this angle. So this just became a lot harder. Now we have the adjacent one. Now that's opposite, and the hypotenuse is still the hypotenuse. So this question's a little tricky if you think about it, because now tan 58, well, if it's going to be this one, 8.2 is opposite, so that checks out. Then adjacent, so TOA using tan. Wow, this is kind of weird. We had to use tangent of an angle we weren't given, and it turns out that this is the right one. All right, so C is right. Then it says solve, and remember, I don't have the split screen for a calculator right now, but tan 58, hopefully you're doing this in your calculator, it's just some number. So we must treat it as just some number. So we're gonna put this over 1, cross multiply. I'm gonna get BC times tan 58. Remember, tan 58 is just some number, equals 8.2. Divide both sides by tan 58. We're going to get BC, and then plugging 8.2 divided by tan 58 into your calculator, you're going to get about 5.1. All right, that's the rounded answer, 5.1. That's it. All right, cool beans. All right. And then this is the same problem again, just a little different. It says in the accompanying diagram, measure of angle A is 32 degrees and AC is 10. What's the equation to find X in triangle ABC? Then solve for X. So again, let's look at this. Given this right here, X is opposite, 10 is the adjacent side. So we have opposite and adjacent. Well, that's going to be TOA. Tangent uses opposite and adjacent. So it's going to be tan 32 equals X over 10. All right. Now, noticing this, none of these are put in this form right here. They're actually a little bit more simplified. They're post cross multiplication. So put tan 32 over 1. Remember, tan 32 is just some number. All right. If you plug in our calculator, we get some bizarre decimal. But after I cross multiply, I get X equals tan 32. Again, the answer was C. Plug this into a calculator, tan 32. So 10 times tangent of 32 is about 6.2. All right, and then last one, number 4. Triangle JKL is shown below. Which equation could be used to find the length of JK? All right. So again, looking at this, with respects to 24 degrees, that's the opposite side. Does not touch it, and then the hypotenuse is always the hypotenuse. So we have opposite and hypotenuse. Which trig function uses opposite and hypotenuse? Well, that's sine. So it's sine 24 equals opposite is JK, and the hypotenuse 28. So in this case right here, it's that right there. All right, this is just ensuring that we're setting up the equation correctly. Now for fun, let's cross multiply and solve. You're gonna get JK equals 28 times sine 24, which spits out 11.4. That's it. All right, stay tuned for more.